Probably most of you are not familiar with these Canopy sensors. So I'll start with what are these things? And they're things that look down at the crop from a moving fertilization machine and evaluate its appearance. And based on what they see, the information is taken into a computer in the cab and nitrogen rate is calculated, and then it directs a controller. And the controller in this particular case, it's an anhydrous ammonia applicator, and it's going to be knifed into the soil, and there's a ball valve back there that opens and closes to change the fertilizer rate. When those sensors see dark green corn, that ball valve closes down and puts on a low rate of fertilizer. And then when they see light green corn, which is going to be more nitrogen deficient and indicate less nitrogen coming available from the soil, it opens up and puts on a higher fertilizer rate. And it's doing that about every second. Why do we need to do that? I started off trying to figure out what was the optimal nitrogen fertilizer rate to put on corn, and we found it changed a lot from one place to another within the same field. That diagnosis of what the crop's nitrogen status is with the crop appearance is more accurate than anything else that I have been able to come up with in terms of deciding how much to put and where to put it. This is a picture that was taken in 2010 near Oskaloosa, Iowa. There's dark green and then there's light green, and they're all intertwined, and so the nitrogen status is highly spatially variable. You can see that the dark green areas match with the red areas, meaning high yield. The yellow corn is green and blue in the yield map, and the darker green corn is yellow and orange in the yield map, and red. Well, the darkest corn was about 170 bushels, the lightest was around 80, and there was a pretty strong relationship that the darker corn yielded more, and the lighter corn yielded less. It didn't have enough nitrogen. The average in the field is 125, and the best was 170. He lost 45 bushels on average over that field. At 265 acres, that's about 12,000 bushels of corn. And at $3.75 a bushel, that's about $45,000. I'm going to share some results from an experiment that we've done in central Missouri. For the first 4 years, with our 140 pounds per acre planting, we made an average of 86 bushels per acre. And with sensor-based nitrogen, when the corn is knee high, we made an average of 142. That's 56 bushels more. And it's because the nitrogen was there in July and August when the crop needed it. Okay, well, that's how sensors may help with adaptation to wet years. What about dry years? I happen to know that there were a number of people who were all planning on in-season application. There are more and more of these high-clearance spinners that can put on nitrogen later, and people who were planning on using those, a number of them opted out. This particular machine that's in the picture does have sensors mounted on the front of it. It can cover a lot of acres fast, and it also gives people an option to pull the plug and not put the nitrogen on and not spend that money and not put that nitrogen at risk in years when the odds that it's going to pay off are low.